If I write 1 minus 1, no problem. This is, sorry, this is 2 minus 1 if I write. Or only one power is there, no problem. This is only 1. So 1 plus h, this is 1 minus h here if I write. X plus y plus z is less equal to h if I write. This is equal to h. So we can write this value in terms of h here. This will give us gamma 1.2. That means, let me convert this value. What is this? Under root pi. So root pi whole cube for gamma 1.2, 1.2, root pi and root pi and root pi and root pi whole cube. This value divided by this is what? Half plus half. 1 plus 2 plus 1 means 5 by 2. Gamma 5 by 2 here. 1.2 plus 1.2 1. Okay, and 2 and half, that means 5 by 2. And this can be then converted into other part we will do. This h raised power 3 by 2 here into this is 1 minus h, okay, into dxt by dz. If I write it as dh only dh, because dxt by dz dh here. So this is the final value, but here 1 minus h whole power 1, if I convert this into that value, h raised power 3 by 2, 1 minus h whole power 1 minus h whole power nothing but only this is 1 here. Okay, now if I convert this into gamma function, then what it will be? Beta gamma function. This will also come out as under root pi whole power 2 divided by this is 3 by 2 into 1.2 into gamma 1.2. This value is, okay, this we will calculate. Now this is what? Beta 3 by 2 minus 1, that means beta half. Okay, and this is 1 plus 1. No, sorry, we add here 1, that means 5 by 2. Beta 5 by 2, or we just write this beta 5 by 2 and this is 2 only. Beta 5 by 2 and 2, because 1 we add here. And if it is minus 1, sorry, we write here minus 1 also, because h raised power this plus this plus this, not minus 1, only this value. Because from all these things we know about this question. 5 by 2 into 2, this will give us this value. Under root pi means pi 2 square into under root pi, pi square root pi divided by 4 upon 3 into root pi, and this is 4 by 3 into beta 5 by 2, again is 5 by 2, gamma 5 by 2, so this gamma 5 by 2 is cancelled out. If I write this is gamma 5 by 2, gamma 2 divided by gamma 1 plus 5 by 2 plus 2, that means 3 plus 5 by 2. Okay, so this is the value, but we have to just find out that what is this answer here. It is 4 pi, it comes out to be 4 pi upon 2 gamma 3. Yeah, it's coming out. Or if I write h equal to sine square theta, that can also be given. H equal to sine square theta. If I write here, it will give us 3 by 2 plus 1, that means 5 by 2. Okay, so this, in this case, 1 h, if I put sine square theta, and it will be cos square theta here, and then dh will be 2 sin theta cos theta, and this is h raised power 3 by 2, or h raised power 1.2 plus 1.2 plus 1.2 is coming out. Okay, we can convert that into in that way also. Let me change this in that form. if I write here 1 minus h is equal to sine square theta, if I put, only then we can solve it in compact form. 0 to pi by 2, the limits we have to put here. H equal to this 0 to 1, limits here. First, if I have taken this 1 minus x equal to, or h equal to 0 to 1, or limits h here. Okay, let me write this question in that way also. Okay, so this is this question, no problem. Now what would this one? If I put here h equal to, let me take sine square theta. Therefore dh equal to 2 sine theta cos theta into d theta. And the limits are h equal to 1, so pi by 2. 1 is sine theta equal to 1, so 0 to pi by 2. And h here is, if I put minus 1, then it will be half only. No, only this 3 by 2 that we take. This is 1 and half, that means 3 by 2. No problem. So this sine square theta, this is sine cube theta. It will give us under root pi whole cube upon this gamma pi by 2, that means 3 by 2, 1 by 2, gamma and half. And this can be converted to 0 to pi by 2. Okay, and this h square is coming out. This value is, this powers are added as h raised power half plus half plus half. With 3 value will come as l plus m plus n h raised power. Okay, so this we know from this extension theorem, from second theorem. In terms of h, we have taken h is minus 1 here. H equal to minus 1 here. So if it is minus 1, then only half will be there. If it is half, then it is sine theta only. Okay, so let me write that. It will be minus half, that means h raised power half. If h is sine square theta, it will be sine theta only. First one is sine theta because this is minus 1 here. From second theorem, it is l plus m plus n minus 1. And fh is this value. Okay. So in that way, this is sine theta, this is cos square theta into 2 sine theta into cos theta into d theta. This comes out to be sine square theta cos q theta. Okay, so cos q theta into, this is only 1 minus h, only 1 minus h. Okay, this is cos square theta because 1 minus sine square theta is cos square theta. 2 sine theta to 2 we can take outside. So final value will be, let me write here. So this is from LOUISVILLE'S theorem. So LOUISVILLE'S theorem says that this is equal to under root pi whole power 3 divided by 4 by 3, let me write here, into under root pi. This is under root pi because gamma 1.2 is under root pi. Now over this 0 to pi by 2, because limits are also changed when we substitute h equal to this. Here limits were 0 to 1 we have taken. Well, this is for beta function. Therefore sine square theta, this is sine square theta into cos q theta. So cos theta is there. It is cos q theta into d theta. So this is converted into gamma functions. Now what is the gamma function in this case? Let me check that. What is the gamma function here? It will give us 4 by 3 into pi only, because 1 under root pi and root pi cancel out. 4 by 3 pi only. And this will be converted by gamma functions. What is gamma functions here? This is 2. So gamma 2 plus 1 upon 2. Gamma 3 plus 1 upon 2 divided by twice gamma. The twice gamma, sum of these 2, 2 plus 3 plus 2 upon 2. Okay, so this is giving us 4 by 3 pi. This is 3 by 2, gamma 3 by 2, gamma 2 only, gamma 2 means factorial 1, no problem, divided by 2 into this twice into this value, this is 7 by 2, gamma 7 by 2. Gamma 7 by 2 is 5 by 2 into gamma 5 by 2, 5 by 2, 3 by 2 into gamma 3 by 2, gamma 3 by 2 cancelled out. The final value will be, let me take 4 pi by 3. This is gamma 3 by 2, alright. Factor 1 is 1. Now divided by 2 into 5 by 2, 3 by 2 into gamma 3 by 2. Gamma 3 by 2, 3 by 2 cancel out. 1, 2 cancel out. It comes out to be 5. Okay, this 2 will come in the numerator. It will be 8 upon 8 pi upon, let's say 15. 15 3 ja 15 3 45. 8 pi upon 45. Maybe some calculation mistake, but question is type of this kind is there. The question type is of this kind. Okay, so answer is, okay, answer comes out to be a fourth question as pi square upon 2. It is coming out to be pi square upon 2 because the limits here is 0 to pi by 2. Sin square theta, cos square theta, it is coming out, not cube. It is coming out as sin square theta. It means sin square theta, cos square theta by there. But it is 1 minus cos square theta. Where is the question here? Okay, oh, I'm sorry. Power is half here. Okay, no problem. Then it's okay. I'm sorry. I committed the mistake here because this is 1 minus h whole power half. I'm sorry. That is there. Sorry for that. Then the value comes out to be, I'm sorry, this into, this is only square here because then square root of cos square theta comes out to be cos theta. Then cos theta from this value, from ds value. So this is cos square theta only. So sin square theta because sin theta into sin theta. Sin square theta and cos square theta. Now the value is there. This is nothing but 4 pi only upon 3. This is okay. This question was, I'm sorry, 0 to pi by 2 or 0 to 1 it was. It was here h raised power 3 by 2. Right? There 1.2 plus 1.2 plus 1.2. 1 and half, that is 3 by 2. Into this is 1 plus h, 1 minus h into power half into dh. It was there. We substituted here h equal to sin square theta, I'm sorry. dh was equal to 2 sin theta cos theta into d theta. This twice is coming here, so 2. This twice we have taken outside. 2 was there. The twice of this is value. What about this? Finally, limits are changed. It was 0 to 1 here. Now it is 0 to pi by 2 because 1, if I substitute here sin theta equal to 1, that means sin theta equal to pi by 2. This is pi by 2 now. Okay, 0 to pi by 2, now limits is okay. This is, I'm sorry, 1 minus h whole power half, it was there. Whole power 1.2, I'm sorry. In that way, this question is now okay. 1.2, this value is 1.2 here. So this is now twice into sin square theta cos square theta. We can go through by gamma function. This is gamma 3 by 2, gamma 3 by 2, 2 plus 1 upon 2, 2 plus 1 upon 2, upon twice gamma 2 plus 2, 6 upon 2. That means gamma 3 only. This is 4 pi by 3. Twice into this 2 to cancel out. Let me take. Okay, so only this gamma 3 by 2, gamma 3 by 2. This means 1.2 gamma 1.2, 1.2 gamma 1.2. Divided by this is factorial gamma 3. That is factorial 2. Okay, so this is 4 pi by 3 into 1.4 into pi equal 100 pi. Let me write here 100 pi into 100 pi into 1.4 here upon 2 was factorial 2, 2 into 1. It is giving us 4 cancelled out. This is pi square upon, it is coming out to be, why it is 4 by 3 or 3 by 4. It is coming out to be pi square upon 4. I think answer is there. Pi square upon 4. The mistake is there. It is coming pi square upon 6, but 3 cancelled out. How 3 is cancelled out? Okay, this 3 is not there. This initial value is, let me take this, that what is the initial value. Here initial value was, out of this value, this twice cancel out. Okay, this was gamma 1.2, gamma 1.2, gamma 1.2 divided by 1 plus 1.2 plus 1.2 plus 1.2. Now let me solve this. What is the previous value? I mean, this is okay. This is okay. This is the value. So what was this value? Let me solve it. So that will give us the final answer. Pi square upon 4 answer is there, but that was mistaken. Okay, this is under root pi. That means root pi whole square divided by, this is 2.5 means 5 by 2. Okay, so this is 5 by 2 here. Was half plus half 1, 1 plus 1 2, 2.5 means gamma 5 by 2. Okay, it's twice into 2 is come out from here. Twice into 0 to pi by 2. This is sin square theta into cos square theta into d theta. Okay, now let me further write it down. This under root pi means pi root pi. This is 3 by 2, 1 by 2 into gamma 1.2 means root pi. Root pi cancel out. This is 4 by 3 pi. And this is twice into of this value, because this is twice here. Okay, this is 3 by 2. I'm sorry, this is 3 by 2 because even numbers are there. 3 by 2. This is by gamma, even function. I'm sorry, this through gamma function I have to convert this. Okay, this is 2 plus 1, 3 upon 2, 3 upon 2 upon gamma twice into 2 plus 2, 4 plus 2, 6 upon 2 means 3. Let me solve it. Does it comes out to be this? This is 4 pi by 3. Same thing is coming. Let me check it now. This is twice. Well, this twice into, I think twice gamma n plus 2 upon 2 is there. This twice is there. So 2 to cancel out. Only 1.2 into gamma 1.2, 1.2 into gamma 1.2 divided by factorial 2 means 2 into 1. Okay, so this, I'm sorry, this answer comes out to be 4 pi by 3. This 2 to 4 cancel out, but 2 to the 4, this 4 in the numerator cancel out. So this 2, 1, 2 is there. So 6 pi square upon 6 it is coming out. I'm sorry, it is not 6, not 4, but 6 it is coming out. Pi square upon 6 answer is there. If there is any calculation mistake, that we will solve it. Okay, so this is the question number 4th we have done. Now let me take question number 5th here. What does question number 5 say? Let me check it. Question number 5 says, or question number 5th now. Question number 5th is, find the values of this value where x, y, z are always positive, but this value is greater or equal to 1. Okay, so let me take question number 5 here. What does question number 5 say? Find the value of triple integral sign. This value is there. X raised power L minus 1, y raised power m minus 1, z raised power n minus 1, okay, into dx dy dz, dx dy dz, okay, where x, y are always positive, but x upon a whole power p, y upon b whole power q, plus z upon c whole power r greater or equal to 1. Okay, so if I take then u, v, w, let me take, then what does it mean? Okay, this is x raised power. What the value of x here from this? We have to substitute there. So let's substitute here. Solution. Solution here. Let x upon a whole power p is equal to u. Y upon, this is y upon b whole power q is equal to v. And z upon c whole power r equal to w, let me take. This implies that what x upon a is equal to u raised power 1 upon p. Y upon v is equal to v raised power 1 upon q. Here this implies that z upon c is equal to w raised power 1 upon r. Now taking ABC to that side, that means x equal to a into u raised power 1 upon p, y is equal to v into v raised power 1 upon q, and z is equal to c into w raised power 1 upon r. Differentiating them, this implies that dx equal to, differentiating them with respect to u, v, w, we get dx upon du equal to this value. This is half, 1 upon p, that means a upon p here, a upon p, let me write like this, a upon p, power is u raised power will be 1 upon p minus 1, 1 upon p minus 1, dy is equal to, it will be b upon q, v raised power 1 upon q minus 1, dz is equal to c upon r into w raised power 1 upon r minus 1. Okay, these are the values of dx dy dz. Substituting these values in this equation, so here u plus v plus w is less than or equal to 1. This implies that here u plus, we have to take u plus v plus w is less than or equal to 1. This we have to take less than 1. Because only then we can solve this question. Condition is of ours is with less than or equal to 1. Okay, then only this value will be calculated. This implies that this whole value equal to, let me take these three integrals. What about x here? X is this value, x equal to a into, here this is x equal to a into u raised power, let me write down, this is x equal to a, but power is a, this a raised power l minus 1, okay, into u raised power l minus 1 upon p, this is l minus 1 upon p, okay, plus similarly b raised power, this one m minus 1 into v raised power m minus 1 upon q multiplied with this into c raised power n minus 1, okay, into w raised power n minus 1 upon r. Try to understand. Into all these values. This is a upon p. Now let me write them here. Then into multiplication, these value dx dy dz. So that means a upon p into u raised power upon P minus 1 into du. But before that, let me write V upon Q, V raised power 1 upon Q minus 1 into W. Okay, C upon N is also there, into C upon N, C upon R, sorry. C upon R into W raised power 1 upon R minus 1 into du, dv, dw. This will come out as du into dv into dw also. Okay, first we have to convert dx dy dr into du, dv, dw. That also be converted. This is the whole value. Now let me summarize and multiply that what are the respective values here. So that will give us final value. Then we have to solve it, that what is the powers of these variables u, v, w, and then give us. So let me take a, b, c. What does it say? Now here a, okay, a power 1, only a raised power l plus l minus 1. That means a raised power l is there. For l minus 1 plus 1 is a power. Upon p is there, this p is separate. So pqr will come, okay, outside. And into b raised power, again this is 1, b raised power n minus 1, so b raised power n into c raised power n, c raised power n only. And this c1 and this is c here, c raised power n minus 1 plus 1, that means c raised power n upon pqr. Here separate values. Integration sign. Now u raised power l upon p minus 1. Okay, so this is, how can we write it? This is l raised power. Okay, these values are also to be added up. So let me write them. So this is l upon p, 1 upon p. Okay, that will be l upon p minus 1 upon p, this value, plus this value, u raised power. That means plus 1 upon p minus 1. Alright. Into v similarly. V raised power is this m upon q minus 1 upon q, and this value plus 1 upon q minus 1 into w raised power, this this n upon r minus 1 upon r plus 1 upon r minus 1 into du, dv, dw. Okay, what do we see here? This is nothing but a raised power l, b raised power n, c raised power n upon p, q, r, integral sign, triple integral. What about u raised power? Now this p cancel out. L upon p minus 1. V raised power m upon q minus 1. Okay, these are cancelled out. And w raised power n upon r minus 1. This 1 upon r cancelled out. Into du, dv, dw. Now this is forming the Dirichlet's theorem. Now directly we can substitute this value. This is equal to a raised power l and b raised power n. Sorry. This is b raised power n into c raised power n divided by, this is p, q, r. What is this? This is simple, because this is m minus l minus 1, m minus 1, n minus 1. This is fact gamma l upon p, gamma m upon q, gamma n upon r divided by, let me write here in curly bracket, this is nothing but 1 plus l upon p plus m upon q, gamma, under the gamma sign, plus within bracket n upon r. So this is the answer here. Simple answer. This is a raised power l, b raised power n, c raised power n upon p, q, r into gamma l upon p into gamma m upon q into gamma n upon r divided by, all these values are substituted, plus 1 sign. 1 plus l upon p plus m upon q plus n upon r This is the whole value under the gamma sign in the denominator. Okay, this whole value is there. So this is the answer here. Final answer of question number 5. This we have done. Okay, now let me take 6th question. What does question number 6 say? Let me check it. So question number 6 now. Question number 4. The mistake by there in answer, I'll take it separately. Okay, that question I'll clarify that how this question by there. Finally, I'll take that again. It's a simple question. Let me take 6th question. What does question 6 say? Prove that. Here to prove. Simply answer is given here. To prove that integral sign up to dx1, dx2, okay, up to dxn divided by this whole divided by square root of 1 minus x1 square minus x2 square minus and so on xn square, okay, is equal to, we have to prove that this is pi raised power n plus 1 upon 2, pi raised power n plus 1 upon 2 divided by 2 raised power n, okay, this is under the gamma sign, 1 upon 2, then bracket n plus 1 upon 2 in the gamma sign in the denominator. Okay, let me take it separately. Okay, so if I take this value x1 square plus x2 square plus x3 xn square less than or equal to h, let me take, and dx1 dx2 dxn. Okay, so that will give us something value. So here this number will be real number when, okay, given function this will be real. Solution here, let me write. Solution, let me write here. This function will be real if the given integral will be real if x1 square plus x2 square plus xn square, this plus xn square is less than 1. Simple. Why? Because this is there.